This week we're going to talk about how to use try and accept to help catch errors, which we know you never make. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I want to show you how to use a structure that I see a lot of Python programmers start using as they develop their coding skills, but maybe not in the most effective way, which is the try and accept structure. So this is a great way to do error checking, and in fact in Python, the best practice is to ask for forgiveness rather than permission. So instead of input screening, say we enter a number, say, is this a number? We just try to treat it as a number. And if that doesn't work, we then deal with that error. And that's exactly what try and accept is designed to do. So let's create that exact scenario. I'm going to create an input, enter number A, and another one, enter number B. A is going to be float A, because that's going to be a string by default. B is going to be float B, and I'm going to print A divided by B. Okay, so we're going to get these little boxes in the notebook. I'm going to say A is 4 and B is 3. The result is 1.3 repeating. So that works. That's great. We can move on with our life, right? That program is complete. Well, we know that users never do anything that we don't expect, or we never miskey something. So what if I enter 4 and D? Well, we get an error. And some of these errors are going to stop your program right there. Some are just going to be, well, maybe a little less serious. But in this case, we can't convert the string to float. D does not have a numeric equivalent, and we fail right there. We never proceed to print A divided by B. And this is a value error. So what can we do? Well, a lot of times I'll see this. Try, which means this is the thing we want to do. And then we'll see something like accept, print, oops. Okay, so if I do 4 and F, we see oops, and then we get a type error. Okay, so there are a few problems here. The first one is not a best practice to use a blank accept. And the main reason is, let's say this is in a loop. Well, you'll have to close the terminal to get out of that loop, because the Control-C that you use to normally stop your program is a keyboard exception, and it's going to get caught by this. So we can get around that a few ways, but really you want to use the most specific error that you can. What am I trying to prevent here? I'm trying to prevent a non-numeric value. We know that is going to be a value error. Okay, so, and also we should have a better message than this. Something like values must be numeric. Okay, so now I'm going to put 5 and H. I get values must be numeric, so that's good. But we're still trying to print this, and that's not going to work because float and string are not divisible types. So now we can use another feature of the try and accept, which is else. The else block runs if the try block is successful. In other words, try this. If there's an exception, do this. Otherwise, do this. So now, if I take 6 and divide it by j, we just get a message that says values must be numeric. If I take 5 and divide it by 4, the program runs as we expect. So this is a simple example, but the try, accept, else structure is very useful, and you should not use those blank accept blocks. Okay, so let's try something else here. Let's say that I put 5 and 0. Well, now we're going to get a 0 division error because we can't divide by 0. So how are we going to do this? Well, probably with another try except block. You could nest these, but I think that's a little too messy. So what I'm going to do is put a try here, say that the result is A divided by B. Except a 0 division error. Denominator cannot be 0. Otherwise, we'll print the result. Okay, so let's try that. 5, 0. Denominator cannot be 0. What about 6 divided by u? Values must be numeric. Okay, but we're getting that type error again. So we need to think about how we're going to structure this a little bit differently. We could nest these. We could also put them in a while true and break on the exceptions. So now 6 divided by u, value must be numeric, and we break out. So there are a few different ways you can handle this error flow, but really doing it is better than doing nothing, but using some of these best practices helps. The last feature of the try except I want to show you is the finally block. So to do that, let's take a look at a case where you might need a finally block, say working with a file. I'm going to open myfile.txt, which is a file that has a couple lines of comma separated values in it, but just a couple. We're going to open it in read mode. The lines, f.readlines. And let's say there's some critical number that I'm going to do a calculation with, and I think it's on line 5. I know this file doesn't have 5 lines, so that's going to fail. Now, maybe I don't know all the different ways that my try could go wrong, but I don't want to leave a blank except block, but I don't want to get as specific as, say, a 0 division error. We can say except exception, which is going to work for most exceptions, but exclude a few things like keyboard interrupt, because that's really an interrupt. Okay, so we can do except exception, and we'll print cannot process file. Now, finally, we're going to close that file. Finally runs whether or not the try is successful. It's always going to run. And this is a great example of when you would use that, closing out files that may be open. Now we get the message, cannot process file. If I change it to line 2 or line 1, there we go, because it's only got 2 lines, then it's going to work. But maybe I want to know what the exception was. We can say accept exception as E, and then add that exception here. So now we see that the problem is list index is out of range. So I hope that you found this useful and that you'll use the try, except, else, and finally blocks to help put a little bit of error checking or asking for forgiveness into your code. I'll see you on next week's MetPy Monday.